already talked about elements. We did this last week when we were still in school, but let's just refresh our memory to say that elements are pure substances. They can't be broken down by physical means or by chemical means. These are the things that are on the periodic table, and they are pure substances. They can't be broken down. We group elements according to their properties into either metals, nonmetals, or metalloids. Metals are the things that are on the left-hand side of the staircase, the things I've highlighted in blue on your periodic table. They are shiny. They can conduct heat. Remember that black square that was shiny and heavy, and it could conduct heat because it made the ice cube melt better. Metals also conduct electricity. You use metal wire in your electricity. You don't use plastic or wood. Metals are malleable. When we say that metals are malleable, we mean that you can hammer it into a foil, like aluminum foil. We also say metals are ductile. Ductile, it means that you can pull them into wires, like copper wire. Nonmetals are the things on the right-hand side of the staircase on the periodic table, the things I've highlighted in red on your paper. Some of them are dull and some are shiny. They are very, very poor conductors of heat, and they're very poor conductors of electricity. That's why the wooden block, the black block that we had last week in the lab, the ice cube never melted on that one because it's a very poor conductor of electricity and of heat. Nonmetals are also brittle. They break very easily. We do say that they're partially malleable. Sometimes they can be partially made into a foil, and they are partially ductile. They can be pulled into a wire a little bit. On the staircase are the metalloids, the things I've highlighted in yellow. They are semiconductors. Semiconductors mean that they conduct heat a little bit, and they conduct electricity a little bit. Not as well as metals conduct heat and electricity, but not as poorly as nonmetals conduct electricity and heat. Some of them are shiny, some of them are dull, some of them are malleable, some of them are ductile. The only one that I'm going to ask you to know specifically is silicon. That's the Si. It's number 14 on the periodic table right here. And that's the one that can be used to make computer chips. Now, when we talk about compounds, we're stepping it up a little bit. Compounds are pure substances, meaning that they can't be broken down by simple means. But they're made of two or more elements that are combined chemically. Let's refresh our memory on what a chemical combination means, or what a chemical compound means.
A chemical change is one in which the chemical composition of the substance adjusts to chemical bonds between atoms must be created. While, whether you boil or freeze it, they'll still be warm. It's a type of ammonia, which is just an atoms. An element can be broken down into smaller parts by physical or chemical means. For example, water is not an element, it's a compound. It needs to contain two elements. In this case, it's electric. Electric consists of other elements mixed together. That's a spark.
More about that later on. Oops, I didn't mean to do that, sorry.
A chemical chain.
So, because compounds contain elements that are chemically combined, the compound has properties that are different from the elements that make it up. We've used the example of salt. Salt is sodium chloride up here on the right. And you know what salt is. It's a white powder. It dissolves in water. You're familiar with it. It's delicious. We all love it. But it's made of sodium and chlorine. Sodium, do you remember that video I showed you where these kids threw the lump of sodium into the lake and it exploded? Sodium is a silver metal, and it's highly reactive in water. Chlorine is a pale green gas that is poisonous. If you take this sodium that explodes in water and combine it with this poisonous gas, chlorine, you can have table salt. Not chemically dangerous, doesn't explode in water, it's not poisonous. Other examples of chemical compounds are sugar and vinegar. We've used sugar many, many times. We've used vinegar in lab. These are things where you take different elements and you combine them together. So you see sugar is carbon and hydrogen and oxygen combined together. Notice that sugar and vinegar have different numbers of carbon atoms. That's what these little numbers are. Different numbers of hydrogen atoms and different numbers of oxygen atoms. That's what makes sugar and vinegar be different. They have different combinations of stuff, of different combinations of elements. Now, when we talk about mixtures, we're stepping it up a little bit. So we're going to take a break right here, and we're going to answer some questions on this Google form, and then we'll go back to mixtures in a little bit.